Hey guys, good evening. I hope I'm pretty much audible as well as visible to everybody. So we're going to start today with a big data discussion. So we will be primarily discussing about what is big data and where do we use big data as a technology and what all different things are there in big data. So that's prominently what our discussion will be focused on. But again, so it's pretty much a live session, guys. So anybody who is having any concerns, anything in general also. So it's pretty much a live session. I'm monitoring the chat. So please do put up your concerns in the chat. I'll try to take that. Okay. So we can start. So today, guys, our agenda is to talk about big data. So giving you an introduction towards what is big data. So even before that, you need to first understand what all different things we do have in big data. So even before big data, what is the data first and how exactly, when is the point where I'll be saying that, okay, now this data is a big data, right? So all those general questions we need to understand. Obviously, we need to find out why exactly we are calling this as a big data. So what is there in it so that we call this as a big data? So all of these points pretty much what we are going to cover in this discussion today. So that's pretty much what our agenda is. So we'll talk about that. Just give me a minute. I'm getting an issue in this. Yeah, cool. So here, as I said, we have to first understand what is this big. So what do we mean by this big when I say big data, right? So when exactly I'm going to call the data as a big data. So understanding this big is very important. So what is this big in the big data? That is what my primary concern is. And obviously, then once we understand what is this big data, so certain properties, right? So certain characteristics of it, right? So what are the different characteristics? We're going to talk about that, different types of big data. So we're going to talk about that. We're going to talk about advantages. So why big data, how exactly it is going to help us doing our thing. So all of these pretty much what we are going to cover. So characteristics, the basic characteristics of my big data, the types, the different types also. So we're going to discuss on that. But before that, my name is Arpit Jain, and the reason why I'm here is because I really like sharing my expertise with people, and data science is my true passion. And as far as my experience says, I am pretty much having 10 plus years of industrial experience into multiple different technologies, into different industries. And I'm also a public speaker, so I do talk to students regarding their career placements, jobs. So anything in general also, please feel free to reach out, and I'm always happy to talk. Cool. So today's agenda, we are going to talk about big data. So big data, first we'll try to understand what is a data, right? So definition of a data, we'll try to understand that. And then we talk about what is this big data, right? So on the data, then what exactly a big data is? When are we going to call the data as a big data? Post big data, we are now trying to understand the types of big data. So types of big data, we have three types. So we're going to be talking about that. And then we're going to be talking about the characteristics. So we have certain characteristics of my big data. And then we're going to talk about at the end advantages. So these are the prominent topics which we will be discussing in our today's class, guys. So let's get started. So very first thing is data. What is a data for you? What do you understand from a data? Any piece of information, anything which is surrounding you as an information is pretty much a piece of data for you. And prominently, there are two types: qualitative and quantitative. So qualitative means what? If I say my favorite holiday destination is, say, Shimla. right? So there is no number associated with it. It's more like my favorite holiday destination is Shimla. Again, it's a piece of information, right? I'm telling you one information of mine. So that information, which is not numeric and which is more like a information in terms of you, in terms of my qualitative data. I'm not talking about any number here. It's more like an objective information here for me. So that is where I'm going to call this as qualitative data. So anything which is still a piece of number, but not necessarily a number for me, right? Still a data point, but not necessarily a number. That is prominently termed as qualitative data for me. The next is quantitative data, where we prominently talk about numbers. For example, I say, I bought 1 kg apple today. His age is 35. Salary is say 20,000. So all of this where I have certain piece of number involved in terms of data as piece of information, that is where we're going to term this as data. So any piece of information which is either qualitative in nature or quantitative in nature. Qualitative means more like an adjective information. Quantitative means more like a number for me. And that is going to be termed as my data point. Okay. Now let's try to understand the big data. What exactly the big data is then, right? So big data is a collection of data that is huge in volume and yet growing exponentially with time. So data which is very huge in the volume, and obviously it is growing exponentially with every passing time. So it is a data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. So the problem is the size of the data is so huge that it becomes very difficult for any management tool to store, to process, and to analyze this data, right? So basically it's still a data, but in a huge size. So now the problem is, who defines this huge? What is this huge? It's still a vague term, right? So thinking from this perspective, honestly speaking, it is still very dependent on what infra you are dealing with. Okay. Now, for example, as I have been always given this thing, so for an Excel file, we have certain limitation of number of rows and number of columns, right? Suppose the size of a file goes beyond, say, a GB or so, it becomes really slow and becomes really tricky to process things on Excel file. Haven't you already experienced it, right? So the moment the size of my data increases beyond some late 100 MBs or some GBs, it start acting up, right? So for Excel, maybe a GB of data is a big data, which is still falling in this definition of the big data, which is so large and complex for the tool to store and the process and use it efficiently, still following it my definition. So from this infra perspective, big data for an Excel file could be a GB of data, again can be called as a big data. So technically, if you have to kind of understand the big data as a concept, any data point which is huge, as simple as that. Huge, when I say huge, prominently I'm talking about in terms of number, the volume. Now, when the volume is so large, when it becomes difficult for the infra to process, store, handle it, then is the time we're going to call this as big data. And obviously, maybe for a Python, a few GBs of data is not even a problem. In fact, technically, Python has no limitation. It is prominently on the infrastructure which I'm trying to solve. Suppose I'm using the data Python libraries such as pandas for my cleanup. So obviously pandas start acting up if my data file is beyond certain odd 4-5 GBs of data. So it becomes really slow post that. So again, I can say maybe pandas as a framework has a limitation, and for that maybe a 5 GB of data is a big data. So it's pretty much a relative term, but for Python in general, I do not have any limitation. Python in general does not have any limitation. I can put up any number of data, any file size. Obviously, it is very dependent on the infra which I'm dealing with. So I need to have the respective infrastructure to process that file size as well, right? But in general, if I have to talk about big data as a kind of a notion or kind of a concept, so you can imagine the data which is so huge and so large and in the volume, so that it becomes very complex for the traditional management tools to store, process, and use it efficiently, right? That's where it started becoming a challenge. And that is where the big data concepts comes into picture. So a lot of different techniques, a lot of different frameworks, which are now acting on top of my existing framework so that it can handle such big amount of data, right? And when I say about the big data, it's not only when I say it's not only about talking in terms of the volume. It's also about a lot of other things as well. Like for example, I say now I have different type of files coming into picture. So for example, go to a social media platform like Instagram or Facebook. So you might be seeing different pieces of information. You're seeing the short videos, you're seeing the posts, the comments, the images. So many different types of data is getting generated on the platform, the social media, right? So big data is again having a challenge not only with the volume, but also with the variety of data which we are dealing with. So different types of data obviously imposes multiple challenges. I cannot apply the same logic to harness the information available from a CSV file to an image file. I cannot do that. Obviously, to extract the information available in an image or to extract the information available in a video, I need to have the respective strategies in place, right? So obviously dealing with different varieties of data, with obviously having a complexity of the volume, it just adds up to my troubles. And that is where the big data computation comes into picture. So all of these pretty much becoming the characteristics, the type, the properties of my big data. Just to tell you a few standard examples, New York Stock Exchange. So New York Stock Exchange is one of the very standard examples of big data where almost a terabyte of new trade data is getting generated per day. Can you imagine? A terabyte of data is getting generated for the trade per day. And imagine the different exchanges we are having in across the globe, right? So imagine the information which we every now and then. Example. So I would say one stock exchange here from New York Stock Exchange is generating a terabyte of data right now. I mean, every single day based on my trade per day, right? So imagine the time complexity, imagine the data complexity we will be having for multiple such different exchanges. And if we have to take a leverage of all of these information and trying to use the data points, you can imagine the complexity to process this 1 terabyte of data so that we can now further kind of say that, okay, now in future, maybe a day after tomorrow, what would be the trend? So I have to first process this information. And before processing, I have to first store this data. So all of these things become very important. So New York Stock Exchange data is one of the very standard big data example where almost a terabyte of data, new trade data is getting generated per day, right? Another very interesting example, social media, guys. So social media, as I was talking about, we have so many different data points which we are generating. We are talking about the posts, the uploads, the photo, video, messages exchanges, comments, right? So all of these are my different data points which we are generating. And you know that one of the very standard statistics has shown that almost 500 plus terabytes of data is getting generated on Facebook in a single day. Just imagine the amount of data we are generating. 500 plus terabytes of data per day, which is getting generated on Facebook. And Facebook is able to store this And obviously, if I'm storing it, I'm able to process it in future as well, right? So imagine the kind of complexity we're dealing with, guys. 500 terabytes of data getting generated per day, and we're talking about months and months of trend, right? That is where the big data computation comes into picture, right? That is where we talk about how we can handle things. Guys, apologies. I think I got dropped. There was a power cut at my place. Apologies for that. Okay, let's quickly come back to our point. So, what I was talking about is social media. Just imagine the kind of city we have in terms of 500 terabytes of information when I'm trying to harness on big data here, right? So, for the social media alone, I'm generating on Facebook 500 plus terabytes of data. Just imagine the complexity we're dealing with. So, obviously, storing this much of information itself is a tricky task here, where we say that now we are going to process or store this much of data so that it can be used for certain trends in future, right? So even another example interesting we're going to show you from the airlines industry. Do you know that a single jet engine can generate 10 plus terabytes of data in alone 30 minutes of a flight time? And just imagine the thousands flights per day across the globe, how many data is getting generated, right? And it is in petabytes. So again, on the very regular things which you are actually experiencing in your day-to-day life, everything is generating so much of data, so much of information around you. In fact, all of this has to be stored, has to be processed, and in fact, once it is processed, now we should be able to help the business take some decisions on top of that. And that is where the information comes into picture, right? So that is where I say now jet engine alone, if can generate 10 plus terabytes of data in 30 minutes of flight time, just imagine the different information which is getting generated from different flights, right? So likewise, every single common day example, you can see the data is just flowing up, right? In general, if I have to talk about the big data types, there are three types: structured, semi-structured, and unstructured. So standard three types of the data which we could see: structured, semi-structured, and unstructured. So structured is nothing but where we call this as a tabular information, tabular data, more like rows and columns. So I have the tabular data here. I'm talking about rows and columns, right? So rows and columns means obviously I have certain rows, certain columns, more like a relational database. We have a concept called as RDBMS, Relational Database Management System. So structured data, where the data is prominently getting stored in a tabular format, rows and columns predominantly. Semi-structured data, I'm going to talk about certain semi-structured format. It could be in XML files, it could be HTML files. So where I still do not have rows and columns, but I still have the data in a parent structure. So that is pretty much where I'm going to talk about having the data in the semi-structured format. The third is unstructured data, where I'm going to talk about images, I'm going to talk about videos. So all of these things would come under my unstructured data. So all of these, as you know, like as I've said in the social media post also, we are uploading so many images, so many videos. And in fact, if you talk about the static pages available, so we are talking about having things from XML perspective, the raw native data structures, XMLs, HTMLs. So those will be marked as my semi-structured data, where still we have certain set of format, but I do not necessarily have the tabular structure. So format plus table, that's pretty much we're going to talk about in structure. So it's going to be format plus table in structured, and in unstructured, we're going to only talk about format plus no table. So that's pretty much what do we have in unstructured data. So with this, moving ahead, let's try to understand each one of them in detail. So structured data, as I was talking about, any data that can be stored, accessed, and processed in the form of fixed format is termed as structured data. So formatting is very important. So format is very important. So I have a format like a table here. I have certain schema. I have column 1, column 2, column 3, column 4. So all of this has to be mandatorily fixed. So I have a fixed format of information which I'm trying to use and set up the data on. I have the fixed format of things here. And on this fixed format, the data is getting added up. That is where I have the structured data coming into picture. And obviously, we predominantly talks about a tabular format of data, and we talk about normalization standards, right? So for a structured data, we always say that we have certain tabular structure. So we have certain normalizations, so I cannot have duplicate rows. So certain concepts such as primary key, foreign key, all of these things comes into picture, where we are trying to establish the relationship between multiple such tables, and based on those multiple such tables, we are eventually having some bit of information from where we can identify how the data would be available in terms of structured tabular information. And however, nowadays we are foreseeing issues when a size of such data grows to huge extent. Typically, sizes are being in the range of bytes. Obviously, as long as my I think we lost. So yeah, as long as my data size keeps on increasing, my tabular data keeps on increasing, I have multiple such rows, multiple such columns being present in my data set, right? And which will eventually add up to the problems, right? That is where the problem will start happening. And we'll see that how exactly we can get into those structures once we have those zettabytes of information available from the structured data. Obviously, processing will become challenging. Storing will become challenging here. So, and likewise, the respective framework, the big data analytics, the big data computation helps and gets into picture to have the multiple extent, the huge extent of data for storage and processing purposes. Then we talk about unstructured data. So in the unstructured data, where we say that unknown form or the structure is classified as unstructured data, where I do not have any format, no format. In addition to the size being huge, unstructured data poses multiple challenges as well in terms of processing or deriving the value out of it. For example, we talk about text files, images, videos, multiple such files, right? So all of this, you can imagine, I do not have a fixed format. I'm talking about a data where I do not have a fixed format of anything. I'm still talking about a heterogeneous data source coming from different places. But unfortunately, most of the time in industries, this is what we get. Now imagine that I'm trying to solve a business problem where I'm saying that what will be the recommendation of the data set for this Facebook post, like, or maybe I'm trying to see, I'm trying to analyze the data based on the video reels which is coming. I'm trying to put some sentiments on the video feeds coming up on Facebook post. So imagine the kind of complexity it holds. First of all, the data volume is so large. I need to store that data. I need to process it, and obviously, the processing it is in fact going to show you different problems. And we have to harness that information, and eventually, based on this, I'm trying to do some analytics on top of that. So unstructured data where I do not have any particular format, but still I'm trying to process it. I do not have any tabular structure. I do not have certain rows or columns information. I'm talking about unknown sources, heterogeneous data sources, where the values will be coming up from different files. So images, videos, and whatnot. I got a question from Pranshu. Hello, sir. I'm working in MNC as a fresher in a different technology, and sir, I want to go data science. How to manage time daily for studying data science? 1 hour is enough. Yeah, I mean, see, I cannot comment on per hour. I would say 1 to 2 hours still decent enough to start your career. How to manage? I mean, see, if you are willing to really go towards data science, then time, honestly, nobody has time. You have to take out time, right? So if you are determined that you have to go towards data science, so please, yes, 1 hour, 1 or 2 hours of study is fine. But again, structured learning is very important. That's where you need to have a roadmap, like you start from this. So try to follow a particular pattern. And I think 1 or 2 hours per day should be fine, Pancho. Cool. The last is semi-structured data. Semi-structured data can contain both the forms of data, right? So here we are predominantly not talking about not having any particular structure or such. So where might not be in form of DBMS, where I'm going to talk about the relational database, where I do not have rows and columns, but I still have certain formats like XML files. XML files, I have the tags here and then the data points here, right? So for every single tag, I have a data value here. So I know that if I need to check the header, this will be present under some XYZ tag. If I need to check the body, I know it will be present under some XY, X1, Y1, Z1 tag. So likewise, every single piece of information is eventually present under some of the other tags, right? So I still have certain format. I know that the data will be prominently focusing around these tags only. But do I have a table structure here? Do I have the rows and columns? No, but I still have the format. So I can have the formats, but not necessarily having a tabular structure. And that is where we say the semi-structured information comes into picture, right? So semi-structured, XMLs, HTMLs are my very concrete examples of semi-structured data. Then we talk about certain very interesting characteristics of my big data. We talk about volume, we talk about variety, we talk about velocity, we talk about variability. Let's talk about each one of them one by one. So volume, obviously petabytes, zettabytes of information is very, very, very tricky to handle. And we have already seen some traditional examples. So we were talking about the data coming from the social media posts, right? So Facebook. So Facebook alone, it generates 500 plus terabytes of data per day, right? An engine generates 10 plus terabytes of data in half an hour of flight time. So when I talk about volume, so volume where the volume is so huge compared to my infra which I have, it becomes really tricky to store it, process it, and then obviously further efficiently use it for getting the information out of it. So that's where the prime characteristics of big data comes, the volume. So volume is very important here. We talk about the magnitude of my data. We talk about the volume, the size of my files which I'm dealing with. Obviously, for Excel file, as I've told you, maybe a GB, 1 GB of data is tricky to handle. But similarly, for other infrastructure, I'm able to process petabytes, zettabytes of data as well, right? So prominent characteristic of a big data is first volume. I'm dealing with very huge volume, which I'm trying to talk about here, right? Next, we talk about variety. So variety also, we have been discussing about the variety. So multiple different data sources. I have been talking about data coming from images, from post, from comments, from videos. So all of this from XML files, all of this is pretty much a data for me. So a very traditional characteristics of my big data here is the variety, the different variety of problem statements I am dealing with, right? So that is where again the variety comes into picture. And in our traditional environment, we actually face this every single day. We are dealing with such different varieties of data every single day. In fact, in any business, that's the major challenge. And in fact, we are getting the different data sources information to process. And that is where one of the biggest challenges of big data comes into picture. Big data analytics, that's where we talk about the variety of data coming into picture, right? The next is we talk about velocity. So velocity, it means again, it talks about how fast the data is coming. What is the frequency? Like for example, I say, I have, say, what to say? I have an e-commerce website, okay? So on e-commerce website, maybe I'm having a transaction per second. So per second is the time frame in which I am generating one record, right? So basically I need to understand what velocity I'm dealing with. So it can be per second, it can be per nanosecond also, right? So I'm generating data with different frequency intervals, different velocities. And that is again one of the biggest challenges of big data computation, where we deal with multiple frequencies, multiple velocities of my data. So we need to handle the inflow of data which is coming from different data sources in terms of what time components I'm going to look at. So again, velocity becomes one of the very important parts which we are supposed to handle the data. It's not about the static information. It's not about a one-time data which is coming and getting stored on my system. I'm talking about every day I'm generating 500 terabytes of data on Facebook. So every day I have to deal with this same problem. So velocity, I'm talking about the data getting generated in a recurrent time stamp, right? So velocity is again very important time frame here. And then at last comes about variability. Variability is where I have uneven intervals. I might have ad hoc requests, right? Suppose there's a big billion day coming up, and suddenly during that hours, during that days, I have shoot up usages on my website. The hits has gone up, right? So likewise, I might be dealing with some uneven intervals of my data. So variability, that's where I'm not talking about a fixed intervals throughout the journey of a problem statement. I'm again talking about the uneven intervals where I'm still expected to handle the data which is getting generated, maybe not in a fixed intervals, in an uneven intervals in different velocities as well. So per interval, I could have different volumes which I might generate. So that is again one of the very concrete characteristics of my big data here. At last, now, once we have identified all those challenges, then comes the big data analytics, which is actually working on top of these problem statements and identifying how we can utilize these techniques to help the business taking a right decision. So obviously, businesses can utilize the outside intelligence while taking the decisions with the help of big data analytics. So those data points which were actually not so useful till the time, but now with the help of big data, I can also take help from the data which were predominantly not being used, right? So I'm generating those capabilities to store, to process those data which were earlier impossible to process, right? So that's where one of the very strong advantages of big data comes into picture. Obviously, with this, we are going to improve the customer service. So every single analytics process which we are doing right now is intended to improve my customer experience. For example, you get some personalized recommendations for a movie on Netflix channel. You get some personalized recommendation for your shopping histories on Amazon. You get some personalized recommendations for the food which you have ordered, right? So all of these is pretty much to improve your experience on my platform, right? And that is where the things comes into picture. Ultimately, I'm going to talk about the improved customer service. That is again the end goal for any business here. Early identification of risk to product. So obviously, once we have the big data processing, we have the capability to identify the risks at the right time, right? So the moment we identify the risk, we can take the respective decision before it is too late, right? So again, for any new product launch, any new services launch, if you are able to handle the different sentiments coming up from the different products available online on the post and the medias, I know that maybe this is not the right time to launch this product. So early identification of risks always definitely helps any product or service launch. And with this, we are ultimately going to have better operational efficiency, where any issues, any operational challenges coming up, I know that I have the infra to handle this. So obviously my efficiency will be improving likewise. Cool, guys. So this is basically a very quick introduction towards how the big data computation looks like, how the big data channels look like. So I am definitely open to anything, any questions right now. If you have any questions to ask me, please let me know. I'm more than happy to answer that. But this was just to show you how big data looks like, what is a big data, what all different things comprise in a big data, and then eventually on top of that, we have the task which is in there in front of us to understand how we can leverage the big data computation for our own purposes, right? So which we will be eventually learning with time, and we'll try to understand how we can use big data for that. Cool. So any questions, guys? Anything, please let me know. I'm more than happy to answer that. Okay. So with this, guys, thank you so much for your time. It was really pleasure discussing with people. So we'll meet again with a new topic where we'll try to go a bit deep in some other areas as well. Thank you so much, guys. See you in the next video.